Welcome to the Coventry and Warwickshire Green Business Programme podcast. Subscribe now for more episodes. Welcome to the 18th episode of the Green Business Podcast from the decarbonisation team at Coventry City Council, and thanks as always for everyone for tuning in. I'm Jonathan Howell, Energy Advisor at Cornish City Council, and I'll be hosting today's session. Now, regular listeners will know that we primarily try and bring you tangible and impartial advice on how to improve sustainability and energy efficiency for your business. Now, our last three episodes, as always, focused on the support available in our region, and it also gave some great case study examples of businesses doing it right and what benefits were leveraged for them in terms of cost savings, new markets, and improved CSR. Now, if that sounds of interest, all of our previous episodes are available to listen. The link is on our podcast description to our website, so jump on there if that's of interest and have a go back through those. But for this episode, we were very keen to have a bit of a change of direction, have a much broader discussion on a topic that affects us all, whether we're a normal consumer or whether we're an individual or a business at the forefront of the green industrial revolution. We're going to talk today about mining. Now, by that, I'm of course referring to the raw materials used to facilitate our modern lives, be it telephones, iPhones, computers, electronic devices, and so on, but also in the context of those raw materials vital to driving the transition to a greener future, in particular solar panels and EV car batteries and so on. Now, as a sustainability professional myself, I suppose you could say I'm guilty of pushing the greener agenda a lot. Those that know me will know me, that's what I'm about. But also, we're looking at transitioning away from fossil fuels, perhaps, while not fully considering the wider picture. So this session is designed to educate and provide more information on what is perhaps a contentious topic. Either way, it promises to be a great session today. So therefore, I would like to welcome our guest speaker to the session today, Lucy Crane from Cornish Lithium. Lucy, good afternoon.
Hi, thanks very much for having me on here.
No problem at all. Thanks for joining. So just jumping in then to the to the main discussion as a bit of an intro. Lucy, could you give us a bit of an intro to yourself, if that's possible, just about your role and a bit of background to Cornish Lithium, please?
Yeah, absolutely. So I am an exploration geologist by training. I did an undergrad degree in earth sciences and then wanted to do something a bit more applied afterwards. So I actually went to the Camborne School of Mines, which is associated with the University of Exeter down here in Cornwall, and did a master's in mining geology, which was fantastic. And I was lucky enough to get a job after that with a company that was based just outside of Oxford, but had projects, early stage exploration projects all throughout Africa. So I kind of spent the first few years of my career hiking around Morocco and a bit in Ethiopia with a rock hammer, making geological maps, coming up with targets for us to then test with drills. And we were looking for base metals mostly. So that's the kind of copper, etc., that, you know, is used a lot in the electrification and this energy transition. I then moved down to Cornwall about 7 years ago and joined what was a startup at the time. A guy called Jeremy Rathall had founded Cornish Lithium and was looking at the potential for extracting lithium from the hot waters that used to flow into the mines underground, the geothermal waters. So I joined as a geologist, the first exploration geologist on the team back then. And since then, the company has grown really significantly. We now have we might have even hit 100 employees in the last week. Yeah. And my role has evolved through time from looking at geology and exploration. And I now head up the ESG and sustainability team. So ESG stands for environment, social and governance. And in practice, what it means is my team's looking at how can we do this in the best possible way? You know, you mentioned that mining is fundamental. It produces the raw materials that we build our solar panels from, that we build electric cars from, that we build our houses from. But I think it's quite an emotive word, and it's quite often got negative connotations associated with it. And in the UK in particular, and perhaps in other parts of North America and Northern Europe, people kind of associate mining with, you know, people will picture coal miners covered in dust and think of environmental degradation. And it's actually the industry the modern industry is very different to that, or can be very different to that. So in Cornwall, we're looking to produce lithium from two different sources, one from geothermal waters, and the other half of the company is looking at producing lithium from granite rock. So they're very different project contexts, but the kind of fundamental ethos of the company is we want to do that in the most responsible way. So what does that mean in practice? Well, it's evaluating what technologies are out there to allow us to produce lithium, you know, in a much more energy efficient way with a much lower carbon impact than perhaps the status quo. But we're also looking to produce battery grade lithium products that can be sold directly to, hopefully, a UK battery industry, which will then go into a UK car industry. So really shortening those current global supply chains.
Very interesting. Thank you. Obviously, you're an expert in your field. What first attracted you to the industry as a young person? Did you have an interest in it in any way, or was it something you sort of fell into?
No,
or?
Total accident, really. So I knew nobody working in the mining industry when I was growing up. Yeah. And to be honest, if you'd have told me at 16 that I would end up in the mining industry, I'd have probably just laughed, because who does that? Is that something we even do anymore?
I feel the same myself, to be fair, but yes. I know what you mean.
And so, yeah, definitely more by luck than judgment. I ended up doing geology at university, or earth sciences, because I really liked geography, particularly physical geography, and I really liked science. And it was only during the course of my university degree that I kind of started to focus on, actually, I think this sounds interesting. And then my master's was quite applied, and it was just a great overview to the mining industry. And I originally went into it because I liked the idea of getting to go hiking around, you know, far off places, bashing rocks. But it's actually since I've been in the industry, and I've also been involved in some groups, some voluntary groups such as women in mining and young mining professionals, I started to think, actually, this is a really interesting space to be in. You know, mining has got this bad reputation that in lots of parts of the world it fully deserves. But I think you're much more likely to change something from the inside than you are from the outside. And in my career, I've been very lucky that so far I've been able to kind of focus in on, well, how can we do it responsibly? How can we change that narrative? How can we embrace these new technologies? How can we work with the communities where we are? How can we look at what the environmental impacts are, minimize those, mitigate them? And how can we do things better, really?
It sounds very interesting. I'm probably questioning my career choices as we're speaking now, to be honest. It sounds like a really interesting role you've got. So thanks for giving us a bit of background to that, and we'll come back to more about the business a bit later on in the discussion, to be honest. So but thank you for the start. So let's get going with the wider discussion, and then sort of dive a little bit deeper into the industry as a whole. So just to set the scene for our listeners, can you just give us a bit of background as to the importance of the metals that you're mining, what kind of metals they are and what they're used for, and perhaps also where they come from? Bit of an overview, if that's possible. And then the next sort of question I'll follow into more about the bits that are used for renewables, if that's okay. So if you can just kick off with an overview, if possible, please.
Yep, and I will try and keep it short and sweet, because that is a very big question. So there's a phrase that if something hasn't been grown, it's been mined, which seems quite obvious when you think about it. But, you know, everything that we're using in our daily lives, we've extracted in one way or the other. And, you know, mining really is fundamental to produce so many of the things that facilitate the lifestyles that we have. So they all form in different places. And Cornwall, where I'm sat at the moment, you know, there's evidence of mining happening here going back thousands and thousands of years. There's this beautiful item in the British Museum called the Nebra sky disk, which is supposed to be one of the first kind of scientific depictions of the night sky. So, you know, people have plotted where actual stars were, and it's made out of bronze, which is an alloy of copper and tin, and it's got gold in it. And a few years ago, some scientists fingerprinted where those metals have come from. So you can look at the isotopic composition and fingerprint exactly where those metals were extracted from. And it shows, I think, that either the gold was from Cornwall or the tin was from Cornwall, and there's copper from France or vice versa. But it shows that there's metal trade happening internationally over 3,500 years ago, which is nuts. And so, Cornwall has this amazing mining heritage, mostly for tin and copper. But actually, it's underlain the spine of Cornwall as you drive down it. You know, it's one big peninsula, really. There's some topographic highs along the spine. So you go over Dartmoor, you go over Bodmin, all the way out to Land's End and the Isles of Scilly. That's where this granite rock pokes up at the surface. And that granite rock is important in Cornwall for a couple of reasons. One, it's relatively enriched in lithium compared to other granites around the world.
Yep.
And then secondly, it's also fairly hot. So we've got more potential for geothermal energy in this part of the UK than other parts of the UK.
Okay, fantastic. Thank you. So bigger picture then is on a global scale, what metals are typically used within my laptop I'm looking at now, for example, and my iPhone? Presumably they're massively in demand, I would imagine.
Yeah, absolutely. Yeah.
What things are we typically using as an industry overview, basically?
So the thing that we use the most of is iron in steel within construction. That dwarfs everything else. We also, across the world, still produce and burn a lot of coal. And then there's a kind of smaller subset of what you might call, and then copper. We produce a lot of copper. And actually, as we talk about the energy transition, if we want to electrify transport and everything in society, copper is really, really crucial. There's an amazing statistic that I think in the last 5,000 years, humanity's produced about 550 million tons of copper. And estimates are that we need to produce that same amount again in the next 25 years, purely to do with the energy transition and growing populations. So that's just to give you a scale of what's kind of ahead of us.
Got it. Yeah. Well, that perhaps leads me in nicely to my next question then, basically, which is obviously more about the energy, the green transition, which we all know and love. Basically, that's our sort of sweet spot in our program. We're all about decarbonisation, so that's what interests me on a personal level as well. Now, I watched your TED talk earlier, and for those people that are listening that want to have a look at that, the link to that will be in our podcast description. And let me just set the scene here for people that are listening. Lucy opened up with, I thought was a really wonderful opening in terms of, she asked the audience if they thought that she was a hypocrite in terms of supporting mining, but also being very, very pro the green revolution. Because obviously, as we know, mining comes with its own social and environmental issues. So if that's of interest, guys, anyone that's listening, have a listen to that. But on that subject then, Lucy, what are the main metals that we're looking for that are used within our solar panels, our wind turbines, and our EV batteries? Is it just lithium that we're sort of talking about, or are there other bits and bobs as well that make up those components?
Yeah, there's definitely other bits and bobs. So copper really is key when we talk about electrification. But in addition to that, we've got a subset of what people are calling kind of critical raw materials. And they're critical because they're either kind of quite scarce or they're really important to economies and technologies. So within that, lithium is pretty key, and that's because of its use in lithium-ion batteries. You know, it's the lightest weight metal, it's got a really high charge density, so if you want something to be lightweight and portable, then lithium's pretty good at that. But also, battery technologies require cobalt and nickel, for example, and they have their own challenges associated with where they're found in the world. So if we think back to where oil and gas is produced, it's quite evenly distributed around the world. Obviously, there's centres where there's been much more oil and gas production previously. But if we then look at this energy transition, it's going to be fueled by lithium, nickel, copper, cobalt. Actually, the geographic distribution of where you find those metals is really restricted. So there's a few hotspots. So the example of cobalt being produced from the DRC is one that a lot of people know, and there are obviously a lot of challenges associated with that. You know, child miners, artisanal mining, fueling conflict. Nickel, again, is really geographically concentrated, and there's some challenges around that. So we're seeing a lot of issues geopolitically where people and countries are looking at securing their supply chains. But what has also happened is that China has been incredibly smart over the last couple of decades. It's seen that this energy transition is coming. It's worked out, you know, what raw materials are going to be key. And even if they can't produce them domestically, actually the Chinese have been very smart and either acquired the mining projects that are mining a lot of these raw materials, but they've also developed the ability to process and refine those raw materials into something that's of a high enough purity to go into a battery. So that kind of secondary refining step is totally dominated by China. So even if the metals are being produced elsewhere, China has been incredibly smart and had a lot of foresight and kind of set up the rest of that supply chain.
Just drawing on that answer then, in terms of the overall picture, which I think will interest our audience greatly. I'm a consumer and I'm looking to invest in solar panels, for example, for my roof. What I'm keen to look at is the whole life cycle of that as a product, the components that go into making it, the supply chains for the lithium and so on for the solar panels. If we compare that to the equivalent carbon that it would save by not using fossil fuels, could we make a very general assumption that it's a much, even though there are issues socially and environmentally with the product, is it a cleaner product is what I'm getting at in your expert opinion?
Yeah, and I think there's a lot of research out there to support that. So you mentioned life cycle assessments, and these are a brilliant way of actually quantifying, okay, what are the carbon impacts, the water use impacts, the land use impacts associated with producing these things. And they go right back to how these materials are mined, all the way through to how they're produced, the shipping, the transporting, the, assembling things together until it's actually ended up, if it's the example of a solar panel, on a roof. And so there is a lot of research out there using these life cycle assessments, not just looking at carbon impacts, but also other environmental impact categories. And yeah, absolutely, they are better in the long term than the fossil fuel equivalent. But you're right, at the moment, they don't really quantify the social impacts. And so I think there is a lot of work going into how on earth do you do that? Obviously, it's so context specific. And that all comes back to transparency. And we need consumers to actually care where things are coming from, to shine a light on what these supply chains look like, because that's the way that we're going to actually see change.
Perfect answer. Thank you very much, and very well put. So just moving forward then, in terms of best practice as an industry, then how can you? I'm obviously talking about your specific business, but also as a whole, your industry. What things could you do, or can you do, to improve things in terms of the environmental impact and the social impact? I'm thinking things like localize your supply chain. Maybe we can perhaps talk about recycling, possibly. Presumably these metals could be recycled. So what things are in the pipeline to make things better from an ESG perspective?
Oh, yeah, it's a really good question. And you're right. I think certain actors within the mining industry have actually been doing this really well for a couple of decades now, but the industry is just really bad about shouting about it. So you only hear like bad news stories, and they're the ones that stick in people's minds.
Good point. But,
yeah. So what we're trying to do at Cornish Lithium is we're looking at how technology can kind of unlock these lithium deposits that we have down here in Cornwall. So at the moment, most of the world's lithium is either produced in South America from what are called salar deposits. So these are really salty brines that form just below the surface. And you may well have seen pictures of these huge evaporation ponds that they set up in the Atacama Desert. You need a huge footprint to do that. Yes, you're using solar energy to evaporate off the water and concentrate up your salty solution, which has got your lithium salts in. But some of these areas are really water sensitive anyway. So that can have a real impact on the livelihoods of local communities who may be subsistence farmers, and, wider ramifications. Or a lot is also the other kind of half of what the world uses at the moment, roughly, is produced from hard rock sources in West Australia. And, it's crushed up. Then it's roasted, which tends to be using fossil fuels to reach really high temperatures. And then the lithium is leached out. And more often than not, those are then processed into battery grade lithium chemicals in China. So it's really global supply chains. What we're looking to do in Cornwall is produce lithium from different geological settings to what you find in South America and West Australia. So, previously they've been considered unconventional sources, but it really is the advent of new extraction technologies that are kind of unlocking their potential. So half of the company is looking at producing lithium from hard rock. We've got a project called the Trelava project, which is where I'm sitting right now. And it's basically consists of an old China clay pit, which is about half a mile that way. And we're looking to repurpose that, quarry the granite rock from within it. And then we're going to crush it up and extract the lithium-rich mica minerals from the rest of the granite. And then we're using a process which has been developed by an Australian company called the Lepidico process, which allows us to just remove the lithium the lithium salts from the lithium micas, and then we'll process it to form a battery grade lithium hydroxide product on site. So that will be ready to be transported to, ideally, UK-based battery manufacturers.
Yeah.
And, we're aiming to be in production in the next 3 to 5 years, which hopefully will tie up with battery mega factories being in position in the UK.
So make it more localized, obviously improves jobs in this country and so on. So I assume then, by the sounds of it, and this isn't an exact statement, but your method is less environmentally impactful.
We've done a life cycle assessment on our kind of scoping study, which was the initial engineering design for the project, but we're actually doing a much more in-depth life cycle assessment now using real-time data from a demonstration scale processing plant that we're just commissioning at the moment. And I mentioned that in Australia they tend to roast the rocks, so heat them to really high temperatures using fossil fuels, and then that kind of cracks the mineral structure and lets you leach the lithium out. We're not doing that roasting step here. So that's the really neat thing about this Lipidico technology, is that we're using hydrometallurgy rather than pyrometallurgy. So to a simple geologist, effectively we're using a chemistry set instead of heat. And we believe that it should have a much lower carbon impact than other hard rock lithium production around the UK, around the world. And then, as you said, if we can sell it within the UK, and that can go into car batteries that are going to go into UK-based electric vehicles, that's massively shortening that supply chain.
It's definitely a win-win-win, isn't it, basically? And obviously within that comes improved social, the social factors, and in the UK are obviously going to be better than somewhere else. It's more, the governance is better, effectively, isn't it? In
Absolutely.
terms of your methodology.
And then the other half of the company, which is really exciting, is we're looking at producing lithium from geothermal waters. So these are waters that circulate naturally at depth beneath our feet. And our concept is we want to drill boreholes from the surface down to about 2 kilometres depth, where these waters are circulating naturally within fractures in the rock. We know that they're there from historic mining information in Cornwall. These hot springs ingressing into the mines used to be a real pain. If you've ever come to Cornwall or watched Poldark, you've seen that there are engine houses dotted around everywhere.
I have seen them. Yeah. I've been to Tadgil, so I know what you mean.
Oh, well, there you go. And those engine houses were there because they had big pumps in them, because they were pumping out water. So they wanted to artificially lower the water table so that they could continue mining these steeply dipping seams of tin and copper. So some of the water that they were pumping out was, water that's percolated down from rainwater and things. Some of it's groundwater, but actually they had these they used to call them hot springs rising up from depth in the mines. And those are the geothermal waters that we're interested in, because they've been flowing through this lithium-rich granite for tens of thousands of years. The granites have been there for 290 million years. And effectively leached some of the lithium from the rock into the water. So if we can pump that up to the surface, when that water gets to the surface from 2 kilometres depth, it will be about 70 degrees Celsius. We'll then put it through a lithium extraction plant. And again, there's been huge progress made in the last few years in lithium extraction technologies. So there's a kind of suite of technologies that have been developed that all, people call them direct lithium extraction technologies. And what that means is you can selectively remove just the lithium salts from solution. So the lithium is dissolved as lithium chloride, and we will just recover a pure lithium chloride and concentrate it up. So then our concept is, subject to all the right permissions and things, but we're getting there. We will then put the lithium depleted water back down to depth via another borehole. So we're just removing the lithium salts from the water and putting the rest of it back down underground to recirculate, recharge. And then we've also got heat as a potential byproduct. So, it's not hot enough for us to generate steam and turn turbines and make electricity, but actually decarbonising heat is a real opportunity. So we're looking to locate these sites where there's a potential heat user, whether that's district heating for houses, whether that's district heat, it could be used in agriculture and things like that. So that's, again, a really different concept to how most people think of mining.
But it's a great plus point, isn't it, as well, basically, in terms of your bigger picture. So that's a really interesting explanation you've given there. Just out of interest, from both methods you've explained, what's the potential amount of lithium that you can extract, or do you not know, basically?
No, we're doing a lot of work. It's a really good question, because it's so important. We're doing a lot of work to exactly quantify that at the moment, and we're most advanced in the Trelava hard rock project because it's more of a conventional mining project, so it's easier to quantify. So there is an estimate by the UK government that the UK is going to require about 80,000 tonnes of lithium per year by 2030. And people talk about lithium as lithium carbonate equivalent. And it's just because, people produce different lithium chemicals all around the world. So it allows you to compare apples with apples. So the UK will need about 80,000 tonnes per year. We're looking to produce 8 to 10,000 tonnes per year from our projects by that point. So that's 10 to 15% of the UK demand. So we're definitely not going to replace imports, but it's not insignificant. There's also another project down the road from us called Imerys British Lithium, which is looking to produce, again, lithium from hard rock, and they're looking to produce about 15 to 20,000 tonnes per year. So between these two Cornish projects, we could feasibly be producing about a third of the UK's demand by 2030, which would be really neat.
Impressive stuff.
And then the geothermal sites, we're envisaging a number of smaller sites kind of dotted all around Cornwall, which would each be producing, a smaller amount, but cumulatively could be quite significant as well.
And in terms of the overall demand for it, I don't know the answer to this. Can lithium be recycled easily? Is that something that the industry is also looking at doing? I mean, presumably it's in my phone and so on. I mean, we recycle the phone itself, but can it be recycled as a raw material, then repurposed, I wonder?
Yeah, so lithium-ion batteries can be recycled. The lithium, when you recycle the battery, goes into what they call the black mass, which is basically like a chemical goo, I think. And to date, people have bothered recycling the cobalt and sometimes the nickel because that's more expensive. The lithium, although it's feasible to extract it, the economics haven't made it viable to actually bother extracting it so far, which is absolutely mind-blowing because you've gone to all the effort of mining it, processing it, putting it into a battery. It's a much higher purity and at a high grade in a battery. It's just locked up in this black mass. And at the moment, I don't think there's that kind of critical mass of lithium-ion batteries in circulation ready to be recycled to give that scale to make it worthwhile. But from conversations I've had with, with some people, it's also really important as to how these batteries are actually designed. Like, we need to be designing these things with second life applications in mind, and then designing them so that we can recycle and recover things much more easily. And we need to also set up so that we are incentivized to recover these materials from secondary sources, because it's absolute madness if we're still mining primary lithium and we're chucking away stuff that we've already gone to all the effort of mining and purifying and refining. So I think we'll get there. There are some big mining companies across the world that are looking into this in quite a serious way, and it could be that the technology that we're using to produce lithium from our hard rock project could potentially, we're doing a research project at the moment where we're looking at whether we can use that same technology to recover lithium from, a battery. So we are involved in research with that. But at the moment, our main focus is on primary extraction.
That's a really good answer. So thanks for expanding more on the recycling thing. And I think you've just given me a very good idea for another podcast down the line for us, basically, because that is a really interesting sort of topic, isn't it, basically, about the fact that we're still going after the raw material rather than looking at the back end of it in terms of everything. Let's be not just lithium and so on. So, so great answer. Thank you. So what I'm going to do, I'm going to just quickly move on and try and sort of localize things a bit more now in terms of we serve our business community, as I'm sure I explained to you before. So we're about giving guidance to our local businesses, basically. Now, this might be a straight no, but are there any advice that you can give to our local businesses in terms of helping them make the right choice in terms of what products they're buying? Are there any sort of accreditations out there that say this raw materials come from the UK or it's come from so on and so forth, or are there literally no advice you can give in that context at all?
I think it's a really difficult one at the moment because there's no requirement for a lot of the kind of provenance of these raw material inputs to actually be reported. So you might have heard some talk of battery passports, for example, where people are looking at using blockchain technology to verify the provenance of things. So again, this is probably getting far too technical for my knowledge, but my very crude understanding of it is that blockchain is effectively a way of giving you a digital passport so that you can trace the provenance of your lithium exactly back to the mine, you know, when it was processed and where, and the same for the nickel, etc. And so once you've got that in place, then you can determine, okay, well, you can quantify what are the environmental impacts of this exact battery? What are the social impacts? I think that's coming as well. So I think it's in process. And I know that car manufacturers, a lot of them are starting to look at these digital passports, these battery passports. The Australian government have produced an Australian battery passport to verify that stuff that's been produced there has actually been produced there. But what can local businesses look for? I think it's just actually even bothering to ask the question, you know, where do you source these things from? What does that supply chain look like? There's a whole load of guidance out there, and a lot of companies will produce sustainability reports now where they might delve into this in a bit more depth. And if people have the time and the bandwidth to be able to even look at that or ask the question, I think that will be really key. But it is difficult at the moment because a lot of that information just isn't easily accessible. But supply chains are actually very powerful things, and it's like every time we buy something, it's a vote with your wallet, isn't it, effectively? So we do all have much more influence than perhaps we think we do.
Yeah, no, it's a good answer. And I have had companies coming to me that are looking to invest in solar, asking for guidance on, well, where has it come from? What's the supply chain look like? So people are aware of it, which is good advice, basically. So for anyone listening, speak to your supplier, speak to your vendor, and just check that supply chain. And maybe further down the line, there'll be some accreditation that comes in terms of validating where things come from. But for now, use your eyes and just check with your supplier where things are coming from, basically. So good answer, thank you. Right, so just moving on then in terms of, I'm going back on a wider context now, basically, I'm afraid. So in terms of mining in general, we've heard in great detail about what you're doing at the forefront of the lithium side of things. What sort of trends can you see emerging in the mining industry in general on a global scale to help improve environmental and social impacts, or are you leading the way, maybe?
I think the mining industry is probably a lot more advanced in this area than people might think initially. That's not true of every mining company in the world, but especially the big mining companies out there are doing some really impressive things, looking at electric mining fleets, looking at using new technologies, looking at reprocessing waste. So, mining waste that was produced from a copper mine 50 years ago because they were only able to mine it down to a certain grade. Actually, that may well be economic to go back and reprocess now. So there are people looking at that. The mining industry is having to do a lot around making tailings, so waste from mining, more safe. So some of the big news stories that have hit recently in recent years are when there's been like awful collapses of some of these old tailings dams in parts of the world. And, there's been some horrific ones. There was one in Brazil a few years ago, which killed nearly 300 people. There's a big legacy issue with mining around the world. So, people are mining copper and things like that at less than 1% copper. So, yes, if we start to think about circular economy principles, it's actually, rather than just producing the copper, let's look at what else we might be able to produce that has value from that. So how can we be kind of stewards of these resources rather than just making it and taking out the 1% that we want? Actually, can we produce aggregates? Are there any other metals that we can recover in that as well? And how can we, I heard the phrase the other day somebody used, the kind of nose to tail concept that people have for, eating meat more sustainably. How can we actually take everything that we possibly can of value out of that rock if we're going to crush it up? So I think the circular economy is a really interesting concept that's definitely leading the way. There's been a real shift over the last few years as well, as to the social impacts of it, because if it's done properly, mining can actually be a real catalyst for positive change. It can bring prosperity to an area that, if it's implemented properly, can actually last beyond the life of the mine, because we can't get away from the fact that these are finite resources. So I think the mining industry can be a real force for change for good, but it just has to be handled carefully. And, there are some really great examples out there.
No, that's a really good answer, and that sort of ties it together quite nicely at the end of the conversation, actually, because we know, anyone that's listening, we know there's negative impacts that's caused by this. We also know that it's necessary to do this to help drive the green transition. But by the sounds of it from our conversation, there are lots of improvements that can be made to the industry as a whole to improve the environmental impact and improve the social impact. And if we look at I keep using the phrase wider and bigger picture, we look at the bigger picture, we know, all of us in sustainability know, that the climate crisis is looming, it's getting worse. So if we offset the impact of mining, which we know is going to get better, versus land degradation, forced migration, forest fires, all of the negative connotations of what's fossil fuel driven, basically, to me, it's still a no-brainer to do it, which is what I was keen to sort of set the context of the conversation. So I think you've given some great reassurance to me, and I hope to our audience, that yes, this is a good thing, and it will obviously improve with your drive to improve things moving forward here as well. Is that a reasonable summary, I think, in terms of the end of the conversation, perhaps, Lucy, that yes, it's much better to do this than to carry on as we're going with reliance on fossil fuels, basically?
Yeah, I totally agree. This energy transition is going to be very mineral intensive. But like you say, what's the alternative? It doesn't look great. Okay, so we need to do it. Need to include the mining industry in these conversations.
Yeah, great. Which is what I was hoping for in this conversation. So listen, thank you. That is it for today. So you'll be glad to hear. So thank you very much. That was really, really interesting. And I'm sure, to be fair, we could carry on for a lot longer, but I'm sure you've got plenty of other things to do today. So listen, thanks very much for your time. It's really informative. And again, I'm going to point our audience at two things in our podcast description. Lucy's TED Talk is really, really informative. It goes over some of the figures that she's outlined today. That's in our podcast description, but also we'll put a link in there to Cornish Lithium as well, to their website. If that's of interest, again, to our audience, have a look. Really, really informative. And then finally, what I'd like to sort of close by doing is giving you a bit of an overview of what we do. Those of you who listen regularly will know this by now, but the Decarbonisation Net Zero Programme, we are here to help your business effectively reduce your energy use and be more sustainable. So as you probably know by now, we give free energy audits, and we also have grant funding available to support those energy reduction projects, such as solar panels, heat pumps, insulation, those things you would expect, basically. So if that sounds of interest, once again, the link is in our podcast description to register onto our programme. So do that, and I'll hopefully see you maybe on site soon. That's all for today. Thanks again to you, Lucy, for joining today. I'm Jonathan Howell. Thanks for listening.